Hello, everyone. Today we are going to talk about a trapezoid. So, definition of a trapezoid. A trapezoid has at least one pair of opposite sides parallel. This means that all parallelograms are technically trapezoids, but trapezoids are not necessarily parallelograms. So, in my trapezoid over here, the top and bottom would be parallel. The other two sides are not parallel. Special trapezoids. An isosceles trapezoid is a trapezoid in which the non-parallel sides, also called the legs, are congruent. So in our trapezoid down here, these two sides are parallel, and then these two, called the legs, are congruent. If a trapezoid is isosceles, then each pair of base angles are congruent. So let's label our trapezoid here as ABCD. So that means BC is parallel to AD. AB is congruent to DC. And that means the angle B is congruent to angle C. That's what that theorem just said. As well as angle A is congruent to angle D. So the angles at the top and the angles at the bottom, if it's isosceles. If a trapezoid is isosceles, then the diagonals are congruent. So the diagonals go from A to C and B to D. So if it's isosceles, those two red lines are also congruent. So to find the measures of the numbered angles, so since this is an isosceles trapezoid, because this line is congruent to this side, angle 2 is also 62. Now to find angle 1, we've got to remember that two sides are parallel. So these blue lines are parallel. And these two angles are then same side supplementary, same side interior. So same side interior angles are always supplementary. So that means angle 1 is equal to 180 minus 62, which is 118. So now here again, I want you to pause and I want you to try number 2. So angle 2 is equal to 79, because those are the base angles of the congruent sides. And angle 1 is 180 minus 79. So it's 101. So now when we look at number 3, pause again and try it. So angle 2 is equal to the 121, because they are the base angles, and angle 1 is equal to 180 minus 121, which is 59. So now we have 3 problems where we need to use some algebra to do these. We're using the same ideas. Here we're talking about sides. Well, the only sides I know anything about are the two that are congruent. So that means x plus 5 is equal to 3x minus 3. And we solve that. And again, we know those two sides are equal because those are our congruent legs of our isosceles trapezoid. So I'm just solving that equation, and x equals 4. Here, I need to utilize my angles. So I know that since these two sides are congruent, that the base angles are equal. So that means 6x plus 20 equals y. But I need another equation because I have 2 variables. So the equation I want to use is along the same side, those two angles have to be supplementary because they're same side interior. So that means 4x plus 6x plus 20 equals 180. So that's 10x plus 20 equals 180. I subtract 20. 10x equals 160. Divide by 10. X equals 16. So now if I look at number 6, LO and MN are congruent. So those two angles are equal. So 7x equals 2x plus 5. We subtract 2x from both sides. We get 5x equals 5. Divide by 5. X equals 1. Trapezoids on a coordinate plane. To show it's a trapezoid, I need to show I have one pair of parallel sides. So that's two slopes. Show it's isosceles, I need to show it has a pair of parallel sides and the other sides are congruent. So that's two slopes and two distances. I can also show that the diagonals are congruent. Two slopes, two distances. I don't like that last way. So, vertices of A, B, C, D, show that it's a trapezoid and determine if it's an isosceles. So to show if it's a trapezoid, I need to do the slope formula. So slope is y2 minus y1 over x2 minus x1. And the sides I want to do the slope on are BC and AD. So when I'm doing BC, my points are -1, 3 and 2, 3. So that's x1, y1, x2, y2. So m is 3 minus 3, or 2 minus -1. 3 minus 3 is 0, so that slope is 0. Do the same thing for AD. A is -3, -1. D is 4, -1. And I know that I want to do those two sides because those are the two sides that look parallel. Remember, parallel means they'll never cross. So it's x1, y1, x2, y2. So m is equal to -1 minus -1 over 4 minus -3. Again, numerator I have 0, so the slope is 0. So that means BC is parallel to AD. So it's an so it's a trapezoid. Now to see if it's isosceles, I want to see if BA is equal to CD. So if it's isosceles, BA equals CD. To find out if they're equal, I need to do the distance formula. So that's x2 minus x1 squared plus y2 minus y1 squared. So when I do BA, B is -1, 3. A is -3, -1. So I'm going to do x1, y1, x2, y2. Then I do the square root of -1 minus 3 squared plus -3 minus -1 squared. And I just do that on my calculator. So it's the square root. So it's the square root of 20, which I can make a decimal if I want, but I don't have to because I'm really just trying to find out if they're equal. So then I'm going to do CD. So C is 2, 3, and D is 4, -1. So again, x1, y1, x2, y2. So it's the square root of -1 minus 3 squared plus 4 minus 2 squared. So that's also the square root of 20. So since BA equals CD, ABCD is an isosceles trapezoid. So I want you to pause And I want you to try this example and then come back and check it. Okay, so I graphed it, and then looking at it, the sides that look like they're parallel are AD and BC. So those are the sides I'm going to do the slope on. So AD, I'm going to do x1, y1 for the A point, x2, y2 for the B point. Slope is y2 minus y1 over x2 minus x1. So I do the slope, so it's -1 minus 1 over -2 minus -1. So that's -2 over -1. So that's just 2. I do the same thing for BC. So I can label B as x1, y1. C is x2, y2. So I'm going to do -2 minus 2 over 1 minus 3. So that's -4 over -2, which is also 2. Since they have the same slope, AD is parallel to BC. Therefore, it's a trapezoid. Now I want to see if it's an isosceles trapezoid. So if it's an isosceles trapezoid, I want to see if DC is equal to AB. So I'm going to do the distance formula. They don't look equal to me. I don't know about you. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And when I do A, -1, 1. So I'm going to make that x1, y1. And B is 3, 2. So that's going to be x2, y2. So I substitute it into my formula. So it's 3 minus -1 squared plus 2 minus 1 squared. Do that on my calculator. And it's the square root of 17. Once again, you can make a decimal, but it's a long, yucky decimal. And I'm going to do the same thing with DC. So D is -2, -1. C is 1, -2. So I can make D be x1, y1, C x2, y2, and do the square root of -2 minus -1 squared plus 1 minus -2 squared. And that's square root of 10. AB is not equal to DC, so it's not isosceles. And that's it for our video today. If you have any questions, please ask me in class.